All right, 3.2 definition part 2. Now we're going to talk about variance. So I'm just pulling the straight definitions from the book. All right, first I'm going to talk about the population variance. So for the population variance, it's sigma squared is equal to the sum of each of your data points minus the population mean squared, all divided by n. So what you're actually going to do is take the difference, square it, and then add that to the next one. And then take all of those and take the average of them divided by n. Now, when we look at the population variance, the sample variance, there's one change to the formula. So it's s squared equals the sum of the difference of the squares divided by, we're not going to use n the sample size, we're going to use n minus 1 instead. Now, there's a big old complicated statistical reason for this. It's something to do with degrees of freedom, and it turns out we actually used one of our data points earlier when we divided by n to get the average, and I don't want to get into a big algebraic discussion of why that is. But the biggest difference between the population variance and the sample variance, other than the obvious sigma squared versus s squared, is that for the population variance, you're dividing by n, and for the sample variance, you're dividing by n minus 1. Now, we're not going to do this by hand. We're going to be using the calculator, and the calculator will show us which is which when we do it. If you recall when we did the video on weighted mean, it gave us a bunch of information. Some of that information is population versus sample variance or standard deviation.